Thank you for coming to the ARC Forum in downtown sunny Orlando. We'll be going to the swimming pool for drinks after the last presentation of the day. Oh, I have the wrong session. So sorry about that. But we'll just have to use our imagination, all right? Yes, this year we're having a virtual forum, that went on last week. It's continuing to this week with the Smart City group and the logistics group. You can always go back to the vFairs platform and look at any of the previous presentation. This presentation will also be available to view here within a day or so. By going back to vFairs, you'll be able to see it. And those sessions will stay active for 3 months. All right. Actually, all of these presentations will then continue on and be available on ARC's, I don't know, Vimeo or YouTube channel. I'm not quite sure, maybe both. So in any event, that's what we will be. That's what will be available. We have some fabulous speakers and panelists today, and I'm not going to introduce each one individually, but as we go to their presentations, we will ask them for a brief introduction of what their background is. And so I'm going to start with a short presentation, and then we're going to continue with a presentation from Jackson Rollins at Duke Energy about his drone program, followed by Eric Schwartz from Florida Power and Light, followed by Steve Luxion from the FAA Center of Excellence, and finally, Miriam will finish up from DRONELIFE magazine. She has some very interesting connections and experience in the industry. All right, let's get it started. All right, I'm assuming you can see my screen. So as I mentioned, here's our speakers. We also have a panelist. Oh, I forgot to mention Jett. Jett from GE Grid Data Analytics will also be joining us. He's quite expert at all things utility from the inspection side, and I'm sure that he'll be able to field some of our questions too. So I also mentioned that and ask Alan to put into the chat window this Mentimeter website or code and QR code. It's just a very short survey. The only purpose of the survey is to start to create a dialogue to involve our panelists, involve our attendees in our panel session. And so it has a few questions here. It just allows you with a simple slider to take that code. No passwords required. It should just go directly. So, ARC has generally been associated with automation, industrial automation, and you can certainly see that in the drone industry, automation is a huge factor. Last year we were going to have Miriam speak, but she was actually in Rwanda talking to the Rwandan organizations there that have enabled this zipline package delivery. It's a little bit easier for African countries that don't have such a restrictive FAA to slow them down, and also a little bit different terrain and a lot less airports and a lot more rural terrain. But in any event, here's just a few examples of some drones. Siemens has working with Sky Specs to inspect wind turbines. Some of these other drones are more in line, from Airbus and Blackfly, and you certainly see that all the airline industry really, Boeing included, have drones coming up. And some of those drones are not just for delivering packages, they're delivering people, all right? I'm not gonna go too long here, but I'm just gonna say that in terms of automation, there's enormous automation in terms of the flight aspects. The engines are automated, the motors and batteries, multiple batteries in series, in separate parallel entities, so that any one failure of a motor and a battery, still keeps the craft able to go there, or able to stay in the air. Obviously there's issues of stability and as in windy conditions. There's the whole issue of navigation, on prearranged plans. The ability to communicate with your drone and what happens with loss of signal is a huge aspect. There's plenty of stuff going on, to with ADS-B and other communication expertise so that a drone knows where it is and knows what other drones and or aircraft are in the area. Then there's a whole level of automation software just on mission logistics, data collection, and data management. And I'm sure that some of our speakers today are going to talk about all of those problems. I did want to mention to everybody that at 3:55 today, that was just a short while ago, the Perseverance drone with the Perseverance rover mission should have landed on Mars and will deliver this very interesting drone, which will be an experimental drone running on the very thin atmosphere of Mars. So if you really wanted to see automation at its best, this is completely autonomous with 12-minute speed of light, 12-minute delay just on the speed of light between here and Mars. It's pretty hard to control this with a joystick. Just very quickly, ARC has covered some of the markets. We did a study a year or so ago on the use of drones in the construction industry. We know that they're very big in agriculture. Utility inspection is a small but growing area. Pipelines, mining, real estate are also growing areas. And if you compare this to drones for delivery, these markets could become pretty small. Drones for delivery will be a huge thing in the future. Part of that is imagining just how far in the future and how long it will take. But when you look at how fast drones have evolved and changed and found new applications in the last 10 years, just imagine what it's going to be in another 10 or 20 years. So that's all I have. And so I'm going to turn this back over to Alan to start our first presentation.
Good afternoon, everyone. It's my pleasure to be here representing Duke Energy. First and foremost, I'd like to thank ARC for welcoming me to the forum and allowing me to share my insights on utility inspections utilizing unmanned aerial systems. A brief introduction: my name is Jackson Rollins. I live here in Charlotte, North Carolina, where I attended school and have a degree in civil engineering. I've worked in the utility industry for almost 15 years and have served in various capacities from engineering and construction management to project management, and now in a role in aviation. At Duke Energy, I serve in two main capacities. First is the UAS strategy for the enterprise and how we can adopt this technology in an intelligent way. And second, I lead the operations of UAS, both within our aviation organization as well as out in the business units, and also manage the vendor network here for today. What I'd like to do is spend some time sharing with you our perspective on the utilization of drones in the utility industry. That is, what we use from a hardware standpoint, how we have structured the organization to implement our strategy, and then some of the high-level challenges that we face that are probably common across the industry. We'll start here with a sampling of our fleet that we deploy for various missions. What many will notice here is that we've concentrated our efforts in the small UAS category and staying within the confines of Part 107, while some of our peers may be looking to fly some larger aircraft that generally don't fall in this category. Our stance has been to try to become as good as we can be under the current regulatory guidance. On the screen, you'll see various platforms from the smaller units within the category up to some of the larger units in the category, such as the Matrice 600. We'll take a little bit deeper dive into a few of these platforms and talk through some of the use cases that we use them for. Shown on the screen here is the DJI Matrice 600, or M600 for short. It's certainly our heavy lift drone here in our fleet, and we've used for some pretty unique missions. On the left in the picture, you'll see a phase 1 camera system, which we'll talk a little bit more about shortly. And then on the right side, you see more of a payload capacity piece of this drone, where we're pulling some string across a body of water to support a construction effort. We've also used this drone for water sampling and other various load handling capabilities. And as previously mentioned, the M600 with the phase 1 100 megapixel camera is one of our more standard use cases. It's a great sensor setup. and allows us the ability to shoot in high resolution and maintaining safe standoff distances conducive to flying a mission safely. In the middle of the screen is a picture of the Phase 1 IXM 100. Recently, we've been using this system to capture imagery that we then turn into a 3D model. And what this allows us to do is have an inspector who otherwise would be in the field climbing scaffolding and basically having some of the more dangerous work that's done from an inspection standpoint. They can do this inspection now from the safety of their home. The next drone that we'll discuss is a little bit of a newcomer here to us and our organization is the Matrice 300. This one's outfitted with a ZenMuse H20T, which provides a 20 megapixel photo, a 23 times zoom photo, as well as an infrared photo with every picture that's taken. We utilize this setup for solar inspections as well as transmission asset inspections that you see there on the right side of the screen. Another sensor package that we have for this drone is some new processing that we're trying out, and it's post-processed kinematic, or PPK. We use that system for orthomosaic mapping, and the PPK system is a form of GPS correction that allows for highly accurate positioning to be established in the imagery. Building on that PPK technology of GPS correction, we have the Wingtra 1. This is the only fixed wing drone that we currently utilize in the fleet. It's a vertical takeoff and landing drone that you can see the process of the takeoff on the left side of the screen and how it sits on the ground there on the right. The main benefits here are the ability to cover a lot of ground in a short amount of time. So we use this drone for a lot of orthomosaic mapping. It has a very nice sensor package, a 42 megapixel camera, and again, along with that PPK setup, provides a very accurate map. We use it on our solar sites and generating stations, and also on our ash basins, which are anywhere from 200 to 1,000 acres typically, and we're seeing very good success with this drone being able to cover that amount of area. And then we have our little workhorse here, the Mavic 2 Pro. It's the jack of all trades here at Duke Energy, and for many aviators, you can liken it to the Cessna 150 or 152 of the drone world. It serves as a primary trainer, the drone of choice that we deploy out into the business units for employees who don't fly for a living. It's our chief aircraft that we utilize on power distribution projects, and you can see here in the middle picture and the far right picture for asset inspections on that system. We utilize this drone for GIS corrections back into our GIS database. And the final drone that we'll cover in this segment is the Elios 2 by Flyability. We use this drone for a host of internal inspections, predominantly at our generating fleet. We've inspected stacks and boilers, tanks, and various other pieces of equipment in an effort to lower hazardous exposure to our workers and also to reduce cost over traditional methods where scaffolding or a longer duration inspection would be expected. So what does the UAS department at Duke Energy look like? You can see here on the screen. We're both a governance and an operations arm in the UAS department. What that means is that we have a fleet of drones, as we previously discussed, and an organization of pilots that I'm responsible for from an operations standpoint. We also have trained individuals out in the business unit where that makes sense, and those folks would fall under the governance of the UAS department, as well as a vendor network that we call on for various missions from storm recovery or some of those use cases that we haven't seen a big enough demand for to really pull into our internal systems. You'll see in the light blue down near the bottom is maybe not an all-inclusive, but certainly a sampling of the various components that are dotted line connection to the UAS department. EHS being environmental health and safety from a sourcing standpoint, and that goes for sourcing drones, sourcing software that we use for our systems, as well as our vendor network. IT and cybersecurity, obviously a buzzword in the UAS space. Security and risk management, a whole host of departments that are tied to the UAS organization as a whole. And then down at the bottom, you have the business units themselves and the end users. So the business units are the ones who are choosing to deploy drones and finding that value there, as we discussed previously, either by mapping or asset inspections or internal component inspections. What about the challenges associated with utility UAS operations? Big data, as you see here on the screen, is certainly a buzzword that and a challenge that everybody faces. The entire value proposition in the use of drones, maybe not entirely, but the biggest value proposition is in the data and the high quality piece of that, and how to get that into the end user's hands so that it's usable. From a storage standpoint, we've faced several challenges. A hard drive is the first thing that comes to mind for a transfer to an end user. It's pretty cut and dry, handing over the data physically, but at any scale quickly becomes obsolete. So we turn to the OneDrive, a Microsoft cloud-based system that we utilize here for the entire enterprise. And after about 6 to 8 months of utilizing the OneDrive for storing data, transferring it to the end user, we ran into some volume issues therein and had to look for a new solution. Most recently, we've been using a SharePoint site. It is an internal to Duke SharePoint site that's kind of put a Band-Aid on the solution for now. It's maybe 25 times the size of the OneDrive, but certainly within a year or two's time, we'll be looking for a more permanent solution. We've started working with our IT department to look at hosting on servers that are dedicated to this type of data, both in the UAS space as well as our internal surveying team. And then there's the transfer of data, where we've taken more of a graded approach. So for small sets of pictures and video, utilizing OneDrive or SharePoint sites can certainly be a viable solution. Some of the larger sets, such as the 3D modeling that we described earlier, in the 500 gigabytes of data range, we have to get creative and look to either external hosting sites or a physical transfer on a hard drive. At any rate, a close working relationship with the stakeholders of cybersecurity and IT and the various components that we talked about in our structure earlier are vital to the success of coming up with the best solution possible from a storage and transfer standpoint. And inherently, the security must be there as well, which is, in our case, what our stakeholders do for us. The next challenge we'll discuss is return on investment. So many use cases have apparent savings associated with drone usage as compared to traditional methods. Take solar inspections as a prime example. So in our case, utilizing drones with infrared sensors takes only a fraction of the amount of time that a full site IV curve trace inspection or a more traditional method would take to assess the overall system health. However, not all use cases are as cut and dry. A lot of time capital is spent in this area determining the viability of a proposed use case or solution. A transmission inspection is another great example where there are many options. In our case, we have the luxury, if you will, of having a utility helicopter fleet alongside the UAS department. And we really look to provide the best value to the customer or the end user and our customer base at Duke Energy. And we really get into what's the data going to be used for. So what is the quality requirement? What's the maybe not the minimum viable product, but what makes the most sense in each case? To play that scenario out a little bit further, on a transmission right of way, a vegetation maintenance inspection can certainly be done with a drone. However, even at 10 or more times the cost per hour to operate a helicopter, we're looking at a fraction of the amount of time to utilize a helicopter to fly some 30,000 miles of transmission line, and therefore would certainly provide the better solution in that case. Flip that on its head, and a detailed inspection of a transmission tower throughout the network, hovering a helicopter in the area and trying to get detailed enough pictures to see cotter keys and that sort of thing, as opposed to sending a drone crew out and being able to knock out several structures in a short amount of time. That value proposition flips back in the favor of the UAS group. So it just goes to say that that careful consideration for all of the solutions is necessary to determine the right course of action. And the same can be said for a software system. In our case, we have a limited number of employees who provide the back-end post-processing of data, and utilizing a third-party software company to be able to churn out data at a much higher rate, utilizing some computer learning in that case, certainly has a lot of value. Another significant challenge is adoption and growth of a UAS department at a utility. So it's going to be very dependent on how you intend to structure the group. For us, we are both governance as well as operations, so it's a balancing act of how many pilots we have within our aviation organization, and comparing that to where it makes sense to have pilots out in the business unit. And a third arm of that is the vendor network that we utilize on a more of a short-term basis, or a use case that we don't have internal to us. At many utilities, transforming for the future is something that's a hot topic, and drones seem to be at the forefront of that conversation in many cases. So you have senior leaders who are pushing for the adoption of drones, and the guidance here is to make sure there's a clear approach with senior leadership and buy-in on how the UAS technology will be implemented across your company. The warning being, without clear buy-in, you could 6 months down the road end up with 3 or 4 or 5 different UAS departments in the various business units who are not cohesive and may or may not be fully aware of the critical nature of aviation as a whole, and the regulations that are part of it. And finally, I'll discuss the challenges from a regulatory standpoint and a system standpoint of those systems that we operate. As previously mentioned, we've made a concerted effort to stay within the confines of Part 107 and operate small UAS. But we do keep a pulse in what the regulatory body is doing, mainly around remote ID and beyond visual line of sight operations. And should the future change for us in finding increased value in those areas, we're poised to be able to operate therein. We are confident that those systems will be robust and will work as designed. We use the airspace authorizations through Lance and have had great success with that, and have been a pretty heavy user of that system since it's been made available. From a system standpoint, we do have Chinese manufactured drones, namely the DJI products, and continue to use those effectively. We've partnered with our security departments, most notably cybersecurity, to ensure that we're doing that without creating any kind of additional exposure for the company. As you've seen, we have also invested in non-Chinese technology, and in an effort to ensure that we're not completely exposed to the potential that there's a ban on those products. And we'll continue to test those in hopes that they become more scalable in the future, and have had limited success with that in our short duration of testing those products. Again, I would like to thank ARC for the opportunity to be here with you today, and I look forward to the live Q&A.
Yeah, so this is Rick. Please submit your questions to the Q&A widget in the bottom. And without further ado, I want to move right along to Eric from Florida Power and Light. Let's see what he's doing with his drone program. Eric, can you share your screen?
Yep, I'm doing it right now. Screen. Okay. Can you see my screen?
Got it.
Okay, perfect. Okay, PowerPoint's up and you can see my video?
We don't see your video, but we see your screen.
Let's go back to. Okay. Video should be up now.
Yep.
Okay, perfect. Well, thank you guys. And as Rick said, my name is Eric Schwartz, and I manage the FPL Air program. And today we're going to talk to you how FPL is using drones to change what we call a 100-year-old process. And this goes into not just drones, but really diving into the side of Six Sigma quality control and really proving out the business case on how drones are more useful and more accurate, more precise than a human driving or walking, doing an assessment down a line. High level, FPL is owned by a parent company called NextEra Energy in Florida. FPL is also part of Gulf Power, which encompasses more than half of the state of Florida. And then NextEra Energy is our unregulated utility that operates our wind and solar fleet in now over 42 states and 5 provinces, I believe now in Canada. On the high level in Florida, we operate in over 35 counties with 9,000 employees and over 79,000 miles of power lines within the state of Florida alone. And to kind of go back, why are we using drones, and what we look at from an overhead perspective is you've got these 5 bullets here to where Florida is one of the lightning capitals of the world. You have a subtropic environment, and I'll brag because I was bragging earlier, it's 80 degrees today, 83 degrees today. And, it's very hot and humid, and bamboo and palm trees and vegetation grows very quickly. And then you've got hurricanes. This past year, we had 5 that made landfall in the state of Florida. And then we also are a peninsula. So you have a lot of salt spray that deals with a lot of electrical issues, from lights flickering on and off to faults and failures. And then also the grid, high level infrastructures like Miami and areas that are highly populated and rely on a lot of electricity. So going back to why are we doing this? Why are we using drones, and why are we trying to continue to improve? And it comes back to the idea of what we've been doing for the past 100 years. And because FPL will be 100 years old since 1925, so in 2025 it'll be our 100-year anniversary. But when you look at the assessment, and it started out with mules and horse buggy carriages, walking, and now of course walking and driving. And you look at the equipment, the overhead equipment, it's 35, 55, and some with transmission, 175 feet up in the air. You are really only seeing at least a quarter to half of the actual equipment, because the other half is above you or it's on the other side of the property if you're on a rear of infrastructure and so forth. And so on top of it, you're relying on humans and trying to use cameras or binoculars or phones and so forth to take pictures of the damage and assessment. And so we kind of look at this as the current approach is manual, inefficient, and inconsistent. And so when you look at this, it comes from, improving visibility, expediting damage and, analysis, mitigating risk, reduction of cost, and ultimately increase of customer satisfaction. Our timeline goes back to 2012 when myself and a few of some coworkers started to use drones as a hobby for Florida Power and Light. And it migrated into 2015 with the first 333s for those of you that have been around this long. And then it goes into, Part 107, which has really changed the way that companies like ourselves, Duke and FPL and so forth, have been able to really operate at a much leaner and easier business model. But the real eye-opener and the real kind of opening of the door, the floodgates, was Hurricane Irma in 2017. Hurricane Irma, to this point, was the largest emergency response drone deployment, where we deployed over 73 drone teams. Within 10 days, we flew over, and the stats here, it says 122 flights, 465 flight hours, but we flew over 1,300 missions, collected over 7,000 images within 10 days, and 73 pilots. First time we ever got beyond visual line of sight waivers under emergency COA and so forth. And that really opened up the opportunity in the business case and really was able to show VPs and executives the true value that drones bring. In 2018, we started to actually deploy into day-to-day what we call blue sky operations, a day like today and so forth, to where we flew over 4,000 miles. In 2020, we have now flown over 15,000 miles, and on our rate right now in 2021, we'll be well over that as well. We average on average, we put up about 10 to 20 pilots in the air a day across the state of Florida. And we're flying anywhere from 10 to 15 miles per pilot a day, depending on the use case and the event or the mission. Kind of going back to our history of storm operations, but it's going to, looking not just now, but also to the future. And what I wanted to show is on really the bottom areas. In 2019, we received permission from the FAA to conduct 2 highly automated beyond visual line of sight flights with what's called a drone-in-the-box solution. So at one of our power generation facilities, when a hurricane comes in, you shut down and you lock up. And what we did is, from 31 miles away, we got approval, of course, with the TFR, to fly using the drone in the box and do a security perimeter search to make sure everything was shut down and locked up. Then when Dorian came through, before the gates were opened and we allowed people back on the property, we were granted an additional BVLOS waiver to where we were able to fly the facility and give a thumbs up that there was no environmental issues, flooding. That area is a very heavily alligator area and so forth. So it was a pretty unbelievable opportunity. But our visual observer and our remote pilot are both RVO and RPIC were 31 miles away. The drone was flown up and landed autonomously, and all the live stream video. And this is a snapshot, the bottom right picture, a snapshot of that flight. And going back to the business case, and really what we did is we started to get to the level of doing true gauge R&R studies, true statistical analysis to prove out the current state, which was walking, driving versus a drone. And we did these blind studies to where we compared the same exact assessment, the feeder circuit, in the same week with one group walking and then another company flying. And you could see to where the accuracy or the precision on the drone side was much higher. On the number of green, the level 5 visual findings, the number was 5, and the drone found 4, while the walking patrollers only found 2 of the 5. And while the thermal findings, there were 12, the drone found all 12, while the walking group only found 5. And then on top of that, what we've continued to do is take it a little further with artificial intelligence and machine learning, to where it's always been the typical assessment when a feeder goes out, you assess the entire feeder. But what we've been working on, and what we call the intelligent feeder assessment, is a machine learning model using smart sensors in the field, AMI meters, and other devices to be able to predict potentially where the actual fault was, to reduce the miles. So not only are we able to more precisely find a potential issue with the drone, we are able to do it by having to assess less than half of the previous kind of process, to where it was 100% versus now we're just above 50%. And now we're actually down to 25%. This is a little outdated by a year. But this not only goes to, going into finding the issue and stopping outages. We also, over the past few years, started to see a lot of privacy concerns and complaints by our customers. You can imagine flying this many drones up in the air, rear of or in front of customers' property and homes. There would be a lot of concerns, and there were. We had incidences where we had rocks thrown at our pilots, shotguns pulled, drones shot out of the sky, and a tremendous amount of potential customer incidences and issues that we had to deal with. So we actually did a research approach to where we did a true focus group. And when I mean focus group, it was really enjoyable because it was the first time I've actually been able to participate one to where I was on the other side of the two-way mirror. And it truly is a two-way mirror in some of the settings, to where you get to watch 10, 15 people, complete strangers, come into a room and just give their honest opinion, good or bad. And so we did that in 6 key locations. And of course, Florida being heavily Hispanic, we did it in Spanish and in English to really truly understand what we could do better. From this research approach, we then decided to change out how we're telling our story. We have a website now to where we show on the screen fpl.com/drones, to where we actually show the exact pictures of what we're taking. We do Twitter, social media, we do newspaper articles, and as much as we can to tell our story. But on top of that, we call proactively every single customer on that circuit. Right now, we're averaging 20 to 60,000 proactive calls a week, to where we're letting our customers know that within the next 10 business days, there will be a drone within their community flying with FP&L. Every vendor or FPL pilot has an FPL hard hat, their badge. They have a vest that says FPL FA certified pilot. They have that center pamphlet that says drone assessment on them to give to a customer. And they have cones and signage that they're able to put up around the community while they're flying. So we're trying to not only be safe for our pilots and our employees, but also a better customer or a better company to our customers on letting them know what we're doing, why we're doing it, and how we're doing it. But it's not just about drones. Before, the Duke story talked about helicopters and other things. We've really taken a multiple level approach to where it is under 55-pound drones, over 55 pound, and also satellite imagery. And there's a mix in between as well, to where, if you look at, there's companies now that can do mobile LiDAR and driving around with high resolution cameras and LiDAR as well to collect imagery from the ground. And it truly is a holistic approach to where there's multiple ways to skin the cat. And we're going to, as a rate-based utility, take the best process that's the best cost for our customers. Another great example in the future is LiDAR and LiDAR with change detection. During one of our storms, we proactively assessed 2 circuits before the storm hit, and that's the yellow section. And then on the bottom is after the storm passed, because we wanted to prove out, number one, could we do change detection on, with machine learning, but also how quickly could we do it to make sure that it truly was not hindering in the amount of time that we needed to. And here you could see that even though there was no damage on the circuit, we were able to identify that before and after in this street, people moved their cars, and we were able to actually detect this autonomously or automatically with machine learning, not doing it manually after the fact. And on top of this, we were able to do it within 6 hours. And so even though it was only 1 feeder, about 3 miles long or circuit, it still shows where the future holds and the capability of what machine learning and change detection with LiDAR is for storm response and also for blue sky inspections. And this is an overall kind of just snapshot of the green and the yellow before and after, just to kind of show the comparisons of what we were looking at for the storm damage model. And then lastly, image recognition. Drones are a great tool, and also helicopters, planes, but you still have to manually assess every single image. On our under 55-pound drone assessments, we're averaging 1,500 images per circuit. That's a lot of images that our vendors, our internal SMEs have to look through to see if there's any issues. And so ideally, we've been working on machine learning. And in this instance, this is called pigment segmentation, to where we're trying to use AI machine learning to be able to shrink the haystack and find that needle and be able to potentially shrink down 1,500 images to 50 or to 20. And so, this is the true future. Without this and without machine learning image recognition, it's going to be very difficult to continue to make drones and large-scale drone deployment on our side a true business case for our customers and our company. And that is it on my end, Rick. Thank you.
Great. Thanks so much, Eric. Fascinating discussion to keep us going, because we are working here till 6 o'clock. I want to move right over to Lux, and maybe we can figure out what this FAA 107 and 333 exemption's all about. Thanks.
All right, thanks, Rick. I'm bringing up my slides now. And thank you very much, Rick and ARC, for providing the opportunity to do this today, and my fellow panelists. It's an honor to be on here with you and the audience. Thanks for participating. I've gone through my slides to speed it up, make sure we have enough time to go through questions on the panel. So I'm going to go through pretty high level and pretty quick. So please enter your questions or save your questions for the panel at the end. But the purpose of this presentation is to highlight where Congress, the FAA, NASA, the government is putting its money to meet ultimately public safety and commercial needs. So if you're not seeing your type of research here, it could be one of two things. We have about 40 projects going on right now. I can't talk about all of those. Or two, the government might not yet be focused on it, and we need to chat to make sure they are. Assure was stood up by Congress to help the liaison, the interchange between industry and the FAA to allow them to fly. Industry, your biggest risk is the FAA regulatory risk on using UAS. You heard some great applications by Duke Energy and FPL, but their operations are challenged by FAA approval. So what we do is we generally take the concepts of operations that industry does, their expertise, resources, call it in-kind support, and we do third-party research for the FAA on usually people, think pilots, operators, systems, the aircraft themselves, communications, and types of operations, power line, linear infrastructure inspections, ag, so forth, and provide the data and information that ultimately provides access to the NAS through regulations, standards, and guidance. So we're trying to fill out the regulatory guidelines and standards so that you guys can operate. Big team, along with our over 100 industry partners. You can see the main universities that we work with day in and day out, all across the United States with different levels and different types of expertise. Also, in the last couple of years, we've increased our international presence because some countries are more willing than others to take part in other operations. For example, you look down there in the bottom left, NTU University in Singapore, and Singapore Aviation Authorities, or it's a city-state, it's an urban. They have no other options but to start looking at urban air mobility. We're not quite ready for that yet in the US. So we're conducting a bunch of the leading research in that area over in Singapore, so that when the FAA is ready, when our industry is ready, and our population's ready, we'll have a lot of the answers already to go. Just real quick, we're not only just the center of excellence for the FAA, we do support all kinds of other opportunities and problems outside the FAA. Through one single contract and one non-disclosure, we are able to reach out to our network, and we build teams to support things like NASA, DOD, Departments of Transportation, government, and industry, and working forward. Now, focusing on our research. And what I tried to do is pick out those key projects that probably are of most interest to you. If you're seeing things here and you're trying to expand in these areas, that's good. But we'd always love to chat with you and learn from what you're trying to do so that we can make sure we enable you through our research. We're in the process right now of finishing up our severity studies on collisions. We did airliners previously, business jets, but now the focus is in that 400-foot and below range with rotorcraft, helicopters, general aviation, and we're also looking at what happens when a turbofan ingests a UAS. And through basic modeling, and then in the future, we're actually going to have a live ingest. In the area of things that will enable your operations, the big ones are detect and avoid for beyond visual line of sight. That's what those two acronyms are for. Detect and avoid is key to operations. So those linear infrastructure lines you heard on some of the emergency authorizations to operate it after an emergency required beyond visual line of sight. We're in the process right now of developing the performance standard for detect and avoid systems. We are validating and verifying industry what they think the standard should be, and then ultimately the means of compliance to enable you to load your detect and avoid system and be able to operate beyond visual line of sight. The second project down there, not integrated, non-segregated, extended operations, means UAS flying unmanned aircraft, drones flying with manned aircraft. And extended operations means beyond visual line of sight. The National Academy of Science got on the FAA telling them that, hey, they are holding back industry. And you are only considering safety in airspace when lives could be at risk on the ground. So part of this group, what they're working on is for different types of operations, different platforms, different concepts of operations, different airspace, and then ultimately different levels of safety. So a disaster or an emergency response to get medicine somewhere or to a fire. The level of risk acceptance for the FAA needs to be higher. And we are working through that right now. The e-commerce is laying out and preparing the FAA to redesign and prepare for the network of UAS that we anticipate and are modeling in the growth in the future to support operations. Now, some multipliers or enablers. Multi-aircraft control will be very, very useful to taking advantage of autonomy. This study is looking at how many aircraft can one person manage or control. And right now we're looking at what are the key factors. And that's things like autonomy and do the systems fly off of each other and the complexity of the operation, the likelihood of an emergency. All of those kind of things are going into the study of determining what the number that can be flown per person. And then ultimately we will develop the regulatory language for the performance standard and then a means of compliance there. We've completed our studies on drones over people and the damage they can cause to humans. And we're in the process of developing a method of compliance to go with the new regulations that have come out from the FAA. Hopefully that'll be completed by late this summer, and there'll be a complete layout of how you can get yourself cleared to fly over top of people. We've also created a validation verification capability within Assure. Basically, it's our inspector general on some of our own research, as well as the standards that are put out by industry, other countries, other civil aviation authorities to validate and verify what is acceptable to the FAA for certain levels of risk. Moving into public safety, big effort is going into what you've heard from Duke Energy and FPL is in an emergency, these things are fantastic where you don't have to risk human life. And what we are working with and have been funded to do, approximately $12 million over 6 years, is to work out an interagency process from the federal, state, local, to better integrate UAS platforms into emergency response. And everything from FAA, how do you get the airspace stood up, integration established, safe integration established. And then we'll probably even start venturing into how do we get the data flows to the right people at the right time. Right below that, you'll see Assure is working with another partner. None of this will work, we found out as we were going through it, unless our first responders are trained in all these things that we're developing at the high level. So we're creating an education, training, testing, and credentialing capability. And Congress has funded us through NIST and FEMA to do that, to demonstrate how we can build a program nationally that will give you courseware, training, testing, and then a database of how everybody has done, so that when you have a problem in the future, you're cleared. You can see, what these pilots or what this company is capable of. For example, FPL could see how their own pilots are scoring against national average and decide if that's good enough for them or not. They need more training, whatever, going forward. You'll also notice that we're really starting to move into more normalized operations. Everything to include operations inspecting towers around airports, fence lines, to actually operations that take off and land from airports. The ability to taxi, take off, fly or departure, get out in the airspace, and then come back and hit an arrival into the pattern and land and taxi back to park are all part of what this study will be over many, many years. It's just starting right now with some of the key areas for us to look at. Air mobility is right now is looking at the business case of where we think advanced air mobility will take place. Is it urban? Is it rural? Is it distribution of medicine? All of those kind of things are where we are. And then if you're looking to be a carrier of people or to move cargo around, the FAA has always used Part 135 regulations, which are really high end. That's your Delta Airlines, that's your FedEx, that's your big aircraft, and the regulations required. Well, we have been asked to then work that Part 135, break it into carrier ops for people, break it into cargo ops for equipment, and do the UAV drone differences for that. There's still a mid-level. You heard a lot of that today from the energy companies. We need a level of certification, and we've been talking to the FAA about that, where you're not doing cargo and you're not carrying people, but you have these long haul inspections to do or communications relays to do. And that's hopefully where we'll find some partners in the future to help out moving us forward and getting the FAA to create some regulations in that space so you can operate. We are also doing some technological research, applied technology research for NASA. And what's interesting here is you start seeing where, kind of the next areas that we're doing. And a lot, as was mentioned earlier, on command, kind of the whole command and control. How do we secure the communications line? Everything from autonomy, how do you secure and make sure the systems are safe and reliable if it's an autonomous system, to the spectrum and interference and things that could happen in a communication system. Yeah, NASA is also interested in multi-vehicle control and multi-vehicle operations, and has asked us to look into the technologies that exist and help to bring forth the most likely ones to mature going forward. Beyond visual line of sight, again, is huge, and everybody is trying to keep pressure on the FAA to keep this thing moving forward. And you can see some of the studies here that the NASA has us doing to help inform them and the FAA in the future on everything from the benefit they provide to what kind of displays are necessary for beyond visual line of sight. Ultimately, out of all of this, the NASA has asked us to develop different concepts of operations, or not develop, utilizing different concepts of operation, build the templates for the safety cases so that companies, utilities can come in and use those to go get certified by the FAA. And then finally, weather is an issue, right? Everything right now in the aviation space is above 400 feet. There's not good weather forecasting below unless you're right around an airfield. And we're working with both NASA and the FAA on projects to do that and help define what weather requirements will be for operations below 400 feet. And with that, I look forward to your comments and questions for the panel. Thank you.
Wow, thanks, Lux. Very interesting. We're going to have a lot of questions coming in on that, but I want to move right straight to Miriam. And so if Miriam, you could share your screen, we're very interested to see your experience. I think you're going to mention a little bit more about delivery.
All right, are we good to go? You can see my screen?
Yep.
Okay. So thank you very much to the ARC for having me, and thank you to Lux and to my distinguished colleagues on the panel. That was, you've set me up nicely for what I'm going to talk about with drone delivery. While people in inspections and utilities and Lux at the FAA are really in the weeds here, as a journalist, I'm sort of a fascinated observer of what's going on. And when you're talking about drone delivery, you're really talking about a lot of concepts, a lot of tests, and a lot of potential. So we'll move on. One note is throughout this presentation, I've used a lot of illustrative photos of drone delivery vehicles so that you could see the wide variety of applications that are out there. But by no means are these the only companies or products on the market. As editor of DRONELIFE, I've written about 3,000 articles on the commercial drone industry since I started in 2013. They haven't all been good articles, but I've written about 3,000 of them. And in the last 5 or 6 years, many of them have been about aspects of drone delivery. When I was preparing this presentation, I realized the first talk I gave on the topic of drone delivery was back in 2017, and a lot has changed since then. So I'd like to update this audience on the state of drone delivery today from a very practical point of view, kind of what's being delivered, where is it actually happening, and what needs to happen before you can start getting packages delivered to your hometown. And I hope that by giving you an overview of the applications happening now, you can see how drones can really play a big part in the concept of smart cities. So before we get started, I want everybody listening to just consider this question to yourself. What is your opinion about drone delivery? If a drone was coming to deliver something to the people next door, not even to you, what do you feel about a drone going over your house? Just think about that. Often when I discuss drone delivery with people, the subject they've heard the most about kind of outside of our industry is fast food. This is an image from 2013 when Domino's announced that it would pursue pizza delivery by drone. And since then, we've seen drone delivery of Slurpees and coffee and burritos and more. But here's a problem with fast food delivery in the US today. So a friend of mine in the drone industry in Virginia was asked to participate in the first Chipotle drone delivery test on the campus of Virginia Tech. And what happened was that the participants were asked to stand on one edge of the parking lot while the drone operators stood on the other side of the parking lot. And a group of representatives from Chipotle stood with the drone operators, loaded up the drones with their burrito payloads, and delivered them, with great applause to the participants on the other side of the parking lot. And then other Chipotle employees came running across the parking lot with their little credit card machines to collect $9 from each of the observers for their now somewhat cold burrito. Because remember that BVLOS flight beyond visual line of sight, is not yet legal without a waiver. So you can't actually currently send a burrito from your local Chipotle to your house unless they can see your house from the Chipotle, or they have a very special permission to do that. So since I haven't made this sound totally appealing, you might be asking why the drone industry is passionately pursuing drone delivery. And there are many reasons. Certainly profit is one of them. Retailers, major supply chain distributors like UPS and DHS have a great deal to gain if they can cut costs and time, even by a very small percentage. But there are more deeply significant reasons why drone delivery can represent a major change in distribution networks. Drone delivery means different things to different people. On the left here is Walmart's drone delivery project, bringing Coke with coffee to residents to introduce the new product. On the right, you see a zipline drone delivery. Rick mentioned zipline before. Zipline is delivering blood supplies to remote health centers in Rwanda. And in this case, drone delivery really equalizes many aspects of the distribution system, and it overcomes some significant barriers. Drones can take the same trip whether there's road infrastructure below or not. They can make that trip without contact with the recipient. During the current pandemic, that's become more important. And even in highly developed countries like the US, drones can deliver life-saving medical equipment and supplies like a cardiac defib equipment. I noticed that Lux's illustration showed one of those without getting stuck in downtown LA traffic. So there are a lot of real advantages to drone delivery aside from sort of fast food or delivering retail packages. Drone delivery, it also has to be mentioned, does mean a lot more than just delivering packages. Some of the same technology and the same regulatory developments on a different scale that support unmanned package delivery can also support unmanned passenger transportation or drones that carry large cargo. This image here is not a futuristic dream scenario. This is the image of a passenger drone carrying city officials in Seoul, South Korea last year. Korea has demonstrated passenger drones across the country. It's committed to having commercial drone transport services within the next few years. China has also put a very short timeline on passenger drones and urban air mobility. In many countries in Europe, here in the US, where the road infrastructure simply can't handle more lanes, you can't keep adding more lanes. There's literally nowhere to go but up. Passenger drones and urban air mobility really represent a huge step forward. So what are the elements that are kind of holding us back from having drone delivery everywhere right now? And there are a lot of moving pieces in the whole ecosystem of drone delivery that need to be considered. There's UTM, which is unmanned traffic management, if you weren't familiar with the acronym, which basically means you got to keep the drones from crashing into each other or crashing into manned aircraft. And with manned aircraft, the FAA is defending an unbelievable safety record here. They have an incredible safety record for the volume of flights that we have in our airspace. And nobody wants to put that at risk. When you have a manned aircraft, you automatically assume that the pilot's going to be able to, if everything else fails, see the other plane coming and get out of the way. The nature of an unmanned aircraft is that it can't do that. And that's where, onboard detect and avoid and other things that Lux talked about come into play. There are security issues. There's the need for data to create those standards. This is still pretty new. We haven't done millions and millions and millions of hours of drone delivery flights yet to understand what the percentages are when things go wrong. We do need to develop those regulations. Possibly we need infrastructure. And maybe most importantly, we need the public to say, yeah, drone delivery is worth it to us. Eric talked about doing that communications work with the community to say, hey, there's a drone going to be in your neighborhood. This is what it's doing. Here's why it's worth it to you. We need that same kind of buy-in from the community on drone delivery. When I say the word infrastructure, I want people to understand that for some kinds of drone delivery, it may actually require building. So when you have a road infrastructure and you have cars, you can't do that without gas stations. You can't do that without all kinds of different infrastructure pieces along the way. And there may be infrastructure pieces required for drones to scale at the level that Amazon vans go past everybody's house. This is actually not from the Jetsons. This is a prototype designed by Hyundai as a transportation hub. We have made some really big progress on things that have all of those challenges. So drone technology has matured. Drones are easier to use. Drones are better at avoiding obstacles. Drones are far more automated than they were back in 2017 and when the very first drone delivery projects were taking place. Some regulations are in place. Flight over people is a really big deal when you're talking about drone delivery in kind of urban environments. Flight over moving vehicles is a big deal when you're talking about drone delivery in urban environments, and the FAA has worked really hard to get those out. Data is being gathered and the public is being educated. This is this image here is actually a middle school librarian. Wing is doing a drone delivery project in Christiansburg, Virginia. This summer, the librarian said, hey, none of my kids can get their summer reading books. Would you be willing to take that on as something you deliver? And they said yes. And that's kind of getting the word out. It's introducing people to the idea of drone delivery as a positive thing. Specifically, the U.S. is moving forward with various programs to bring industry and regulators together to work out the issues of drone delivery. This is people like Lux's group, NASA, all of the elements that are missing, that beyond visual line of sight piece, the unmanned traffic management piece, those are all coming together. In addition, because there really is a focus on making drone delivery viable and having it move forward, the FAA is being flexible. So more drone delivery applications were allowed, for example, during the pandemic. Any program that could potentially assist with COVID response was kind of sped through the system. This here is an image, again, of a Wing delivery drone in the neighborhood of Christiansburg, Virginia. So let's talk about what a realistic timeline for drone delivery might be. And I want to make a note on timelines. You know, when you consider that the very first autonomous car actually made its way across country 30 years ago, and that there was something like 60 years between the first automobile and the development of the first DMV, we're actually moving really fast. The drone industry is moving fast. The regulators are moving fast. Society is moving fast. This is not a slow and chunky process. This is actually moving extremely well when you look at history and game-changing technologies. However, I will tell you that while I can't give you a sort of, it's going to be in your neighborhood by this date, I believe that drone delivery is being implemented first where it's kind of needed the most and where it can be implemented with the least risk. So what we're seeing active at scale now is medical drone delivery. And those are truly life-saving applications. So in a place like Rwanda, where there's limited road infrastructure, the drone delivery of fragile blood plasma to a remote clinic is literally a life-saving delivery. And Zipline is performing thousands of those flights. It's really operating at scale. Here in the US, commercial drone delivery, that's legal for-profit, with a Part 135 certification, is already happening on medical campuses where testing samples can be transported quickly and safely and efficiently from hospital buildings to processing facilities. That means patients get their test results faster. It's really a critical thing in people's lives. Cargo drones are already flying in remote areas. You have them out near oil and gas pipelines where they can deliver parts or equipment on demand. These are really important. Ones that are in remote areas are arguably a little safer too. So where they're most needed, those things are taking place. They are approved. They are actually operating. And as far as retail delivery, I think where that's most needed, it's actually happening too. So for example, the FAA granted permission for UPS to work with a local Walgreens in Winter Haven, Florida, I think it is, to deliver prescription medications to a senior community. So during the pandemic, that meant, those people didn't have to go into a retail store and a delivery person didn't have to travel out into the community and risk exposure. It's really an important application for those people, and the FAA worked with the industry and made it happen. I think other retail applications and passenger drones will also be implemented first in places where there's the most need. As they become more common and the safety data is gathered, we will see drone delivery for things like pizza and burritos. But I think with things like passenger drones, the reason that you're seeing those happen first in places like China and Korea is because there are a lot of remote areas without existing road infrastructure, which could really be economically boosted if they had effective transportation. And just like in some regions, people jumped right to cell phones if they didn't have an existing robust landline infrastructure. At some point, some of these countries are looking at urban air mobility and saying possibly we could jump to air transportation without developing road infrastructure everywhere. So I want to leave you with this. Drone delivery is really not a pipe dream. And it's not about getting toothpaste faster or improving Amazon's profit margins. That might happen eventually. But in the last year, we've all seen that the global distribution systems are a little more vulnerable than we might have realized. And those vulnerabilities can result in an unequal distribution of resources. They can significantly impact the lives of many people. So because the nature of drone delivery is unmanned, in a time when people can't get to work, drones can do a lot of work. After natural disasters or when road infrastructure is damaged or blocked or otherwise unavailable, drones can carry things. And when time is of the essence, drones can fly over stoplights, they can eliminate go right over the traffic jams and the accidents, and they can get an EpiPen to the little kid next door who just got stung by a bee. So with those things in mind, and the realization that what drone delivery is really about, first and foremost, is the fact that you can get from point A to point B quickly, regardless of what's underneath you. Think now about what your answer to the first question was. What do you think about drone delivery now? So thanks very much for having me. Please, if you want to read more about drone delivery, check us out on DRONELIFE.
Wow, thanks, Miriam. Fabulous presentation. And in fact, that's the very question, what do you think about drone delivery, that we'll have in our Mentimeter survey that we're going to go to shortly. But just as I'm switching over to that, what I wanted to mention was that Lux is actually in another presentation with the ARC supply chain sessions tomorrow at 2:30 with Atrium Health to talk about drone delivery in the medical field. So we can all unmute our cameras, or excuse me, enable our cameras and unmute our microphones. But so we just had this session here. So this is what people think about package and food delivery by 2030. People are pretty optimistic, right? I mean, that's one of the highest things. Obviously, the delivery of critical medical supplies, it was the highest single rating. Air taxi service, a little bit hesitancy there, all right? I thought there was supposed to be, I think UAE was supposed to have, who was it?
They do, yes. Dubai has a working passenger taxi system right now. Yeah,
so you could get off your airplane, put your luggage in a drone, and it'll take you to one of 3 hotels, completely unmanned, autonomous. I do have a good spot myself in my own house for the delivery pad, and also I have a good spot for when the air taxi service comes in. That way I could get rid of my cars, get rid of my driveway, wouldn't even need a road. I could just live out here in the country, and just navigate by drone. But I guess I'm a little thinking too far here, right? So inspection of transmission lines was a very big thought would be popular. Drone surveillance, traffic management, drone advertising and entertainment didn't seem too popular. I did see a couple of images sometimes of drones carrying advertising right in heavy traffic in Mexico. All right. So you could imagine you're pulling up to a stoplight and you've got drone advertising with a hanging banner flying by. Wow. Miriam, give me some comments here. What do you think about this drone operations here in delivery? Is this kind of consistent with what you're thinking? Is this where you think people's mindset is at?
Well, I think people ask me all the time when I ride in a passenger drone, and honestly, I'm dying to. And people who say that they're not really on board with passenger drones, they don't have a 17-year-old and a 19-year-old driver like I do in the house. Like, I can't wait for passenger drones. I would be all about that. Self-driving cars, bringing out my dad's 83. Like, please, let's leave it to the computers. But I also think from my perspective, when you see some of these things across the globe, when you look at a really global point of view, it's actually amazing how much is really happening right now. And passenger drones are a great example. EHang's stock just went through the roof within the last couple of months. People are really surprised, but if you haven't been paying attention, but Volkswagen's going over there and talking to them, and there's there's huge investment in Joby Aviation here in the US. Uber Elevate is a big presence in urban air mobility conferences and so forth. I think that is actually a lot closer than people think. Maybe not here in LA or I'm not in LA, but Boston or wherever we are here in the US. But I think that that is going to take place overseas, and as that data comes in, that'll be much more of a reality here in the US. And like I said, I think people's timelines, it's funny because if you ask people when the first self-driving car was, they think it was like 5 years ago, but it wasn't. It was 30 years ago. 30 years ago, we're not getting into our cars and typing in the address and sitting back and falling asleep yet. So actually in the drone industry, things are moving incredibly fast.
Yeah, I think, having some experience with self-driving cars myself, I'm thinking that the problem is in many ways easier with drones. There's a lot less obstacles on construction zones and no policeman with a waving sign you're going to automatically attend. So anyway, we have some questions coming up. And the first question was from Lynn Snowden. She actually submitted this to the Q&A, but and we'd like to share that answer from Duke Energy and then also FPL. The question was, Duke Energy mentioned GIS. Can you talk more about how GIS and drone technology are integrated? That would be for you, Jackson.
Yeah, sure, I can do that. And just FYI, Rick, I think someone muted my camera and I'm not able to unmute it. So GIS, essentially what we're doing with that is through our distribution system. We have a GIS system that basically lays out where all of the components are, whether that's transformers or reclosers, switches, that sort of thing. They're all laid out in the GIS structure that our distribution and as well our transmission folks use. And as you can imagine, I know Eric certainly mentioned it, these are very old systems. So while we know that there's a transformer out on a specific circuit in the distribution system, we don't know exactly where that transformer is. And that could be from many reasons. When it was originally built, the as-builts did not have GPS technology, or they didn't take the time to survey those things in. And what we're running into is, as we get, fine tuning of the distribution system, and that is how much excess power needs to be put out onto the grid to sustain what it is we're doing. The more fine tuning that we can do on that system, the lower the amount of waste that we can create in the generation side of electricity. And so we're flying the distribution system for various projects. Capital projects and future improvements that we're doing, and using simply the metadata from the drone images, we're able to get basically a second benefit out of that project, and that is correcting the GIS system so that the engineering side can do a better job of tuning the system, if you will.
So Eric, clearly FPL, Next Era Energy must have GIS systems. Can you give some comment how you might do it? Do you have the same issues basically as Duke does?
Yeah, it's a similar aspect, right? In Florida, we have over 1.2 million FPL owned poles. We've got over 1 million plus Bell South, joint use poles. And where, the larger equipment is, the more expensive equipment like transformers, poles, but you've got thousands and probably, tens to hundreds of thousands of splices and smaller pieces of equipment. But ideally, where we're going with machine learning is think of it as a virtual assessment, to where when we do our assessments, we're taking about 11 images from different angles per pole, including thermal and visual, and then allowing an engineer from the office to be able to then walk that feeder or circuit remotely while looking at all those different images, and then with machine learning and so forth. So, the nice thing about drones is that every image has metadata, has GIS, has lat-long coordinates, altitude, and so forth. And so you can really pull all that in to consolidate it all within the machine learning model to kind of build out a virtual walking assessment from the air, as we do it on our side. But, the electric utility is still the bulk electric system as a whole, like Jackson talked about, is very old. There's a saying that, it started when Thomas Edison was around. And if Thomas Edison was still alive, it would be exactly the same from the high level of how the infrastructure is set up. And there hasn't been a lot of advancements. In the past 7 years, AMI meters, smart meters have come out, and other types of smart devices. And it's only recently that all that stuff has been able to add to the way of changing the way we do business as a whole. And GIS is a part of that, because if you don't know where something is, you got to go out there and look for it.
So this brings up Jett. Jett works for GE Digital. I've seen some of the analytics capabilities they have for asset management that they claim that they can find right down on where the line is broken, where the transformer is. They can locate these things through AI intelligence. Am I mistaken, Jett? What does GE Digital do with GIS and fault location?
Rick, you're reading my mind. Thanks for pointing the question at me. So just to elaborate in a little more detail with what Jackson and Eric talked about, what we do, we've got a particular product called our Visual Intelligence Platform. We actually ingest the GIS information, whether it's Esri, Small World, or any of the standards. This becomes the baseline. We then take the visual data that's captured in a lot of cases by drones, helicopters, whatever, we're sort of neutral there. We then do a comparison. So we take the visual data as another dimension of how the grid looks. Compare it to the data that is in the GIS, looking for discrepancies. For example, we've been able to find the difference between a cement pole and a wood pole. These are the type of things you can identify on a lat-long basis. You can also apply sophisticated artificial intelligence to look for specific anomalies. You could look for heat signatures on infrared. You could look for corrosion, bird droppings, frayed conductors, and so on, all driven by artificial intelligence. Now, this requires a lot of horsepower. The data is very large. I think Jackson mentioned that in his presentation. So lots of horsepower. This is all done in the cloud. So you have the dynamic computing. But this is a capability that we just released last year. And it's been super popular as far as something that can really crunch this and get to the net result of trying to figure out what is happening in this very, as Eric said, it's a very old and in a lot of cases damaged grid, and a lot of times you don't know where things exactly are at. So there's a lot of benefits that we're finding with capturing this data that are going to drive a lot of business value on both the veg management side, also on the asset inspection side.
So I think we have time for one more question, this one for Lux. Lux, in your presentation, you talk a lot about the FAA and NASA and things. And, one of the questions comes up was associated with cybersecurity. How will the FAA regulate cybersecurity? What prevents somebody from taking over your drone, from stealing your drone, from operating your camera? How can you protect your drone from hacking?
So yeah, it's a big issue, right? Everything from autonomy, having a bad board or somebody getting in the software and corrupting your system, and flight control, all the way up to even your mission data, which is outside the FAA's responsibility. That'll be critical to businesses, that they protect, whoever they're working for, the data. So all of this, and then the transmission of all of that. So what I expect, and what we're doing right now, is we're kind of surveying the key factors associated with cybersecurity, because cybersecurity is everything to everybody, right? It can be all kinds of stuff, but we're trying to lay out what all the different portions and areas of cybersecurity. And what I expect will happen with cybersecurity, very similar to how we manage everything else, for different sizes, different types of operations, the requirements, the performance standards, the safety levels will increase as you go up in magnitude of size, criticality of mission, things like that. The threat of losing a system, the ability to communicate and lose control of an aircraft, which is basically could be a hijacking or just loss of control. We don't care so much about a Part 107, something under 3 pounds, but they'll care more about that air cargo airplane or that air or transport aircraft that's moving people through the city. So those, I suspect how that will happen. There'll be a whole development of means of compliance. We're already talking to a lot of industry and even researchers on different means and methods to certify autonomy and the hardware even and software algorithms that are put in there that they use on Mars rovers that they're developing for those kind of things, because they get zapped all the time by rays from the sun and those kind of things that So they're constantly under attack. So we're trying to take some of that learning and roll it into cybersecurity. There's just tons to be done. And like Miriam said, this is moving fast, but every time we peel back the onion, there's just so much more that we have to figure out to make this thing safe.
Wow. Well, we've come to the end of our session. I want to absolutely thank you guys for some tremendous presentations. We didn't get to all of the questions. You know, we'll try to answer some of those directly to the attendees who asked them. And I would also encourage you, you can you can view this recording in the vFairs platform for, like I say, for the next three months. It will become available on the ARC website, in YouTube, or or some other video channel, but it will be saved for posterity. In fact, you can see that because a lot of parallel sessions go on, that we see a lot of other people jumping on these things, and you see the attendees, the number of people that watch this is actually in some cases tripled or quadrupled. And I'm sure that a lot of people miss things, so right now it's time to go out to the pool. We can go out to the bar, have a drink, and continue the discussion. It's going to be nice and warm out there, so you're just in your t-shirt, none of this frozen ice like we have kind of outside here. In any event, we'll see you at the swimming pool. Thank you.
Thank you.
Thanks very much.
Thanks, Rick.
All right, take care. Thank you.